What's up? I'm Vin, and today we're solving trig equations by factoring. So first up here, we want to find all solutions from 0 to 2 pi to this equation here. And the first thing you want to do is move all the terms to one side. So I would start by subtracting tan theta on both sides. And that's going to make everything equal 0 here. So I'll write this over here. We have 3 times tangent theta, and it's being cubed. So we have tangent cubed theta minus tangent theta. And now this is equal to 0. So this is the factoring technique now. What we could do is we could factor out tangent to the first like this. So we could take out a tangent theta, and now if we divide the first term by tangent, we're going to have 3 times tangent squared. So that's going to bring us here. We have 3 times tangent squared theta, and then minus 1 when we factor out a tangent theta equals 0. And just know, anytime you want to check your factoring, you could always distribute and see that it'll bring you right back to where we left off. So that's the first step here. We went ahead and we moved everything to one side. But now we're going to set each factor equal to 0. So we're going to set, we have tangent theta equal to 0. And we're going to set this factor, we have 3 tangent squared theta minus 1 is equal to 0. Now we're answering this in radians. So first up here, we want to know, when is tangent theta equal to 0? And just know, we could call tangent theta, we could call it sine over cosine like this. And then here, when is a fraction equal to 0? When the numerator is 0 and the denominator is non-zero. So really what we have here, or we could just think of this as 0 over 1 and we could cross multiply. We're really looking for, when is sine of theta now equal to 0? And then from this step, we could just start writing our solutions over here. We're going to have theta equals, and our first solution, sine of theta equals 0 at 0 radians, and then we have at pi radians, and then we have 2 pi radians. Notice the question was asking for solutions between 0 and 2 pi, and we're including the endpoints. But now for the second equation here, we're going to start by adding 1 to both sides. And that's going to give us 3 tangent squared theta is equal to 1. And we'll just make this a little bit neater. And now we just divide both sides by 3. So this brings us to the step we have tangent squared theta is equal to 1/3. But now this is a very common mistake. When you're dealing with something like, let's say, x squared. If you take the square root of x squared, common mistake is students just say x, but what they forget to tack on is the plus or minus. Just know, the square root of x squared is actually equal to absolute value x, not just x. So when we take the square root of both sides here, we have to say that tangent theta is equal to the square root of 1/3. And we could also say tangent theta is equal to the square root of, well, the negative in front, the square root of 1/3, and we have our minus sign on the outside. So now let's close this out. We could close this bracket off and we'll add these solutions to our final solution set at the end. And now we're going to identify the quadrants. And what we mean by that is, anytime you have a trig function that's equal to something that's not 0, you want to set up ASTC. And you could think of this as all students take calculus. There's fun ones like all students take crack, all strippers take cash, whichever one helps you remember it. But what you really need to know is that if tangent theta is positive, we know all the trig functions are positive in quadrant 1, and tangent is positive in quadrant 3. So our solution to this one here is going to be in quadrant 1 and quadrant 3. So now we just have to simplify this a little bit. This, we could say the square root of 1 is 1 over the square root of 3. We're just going to call the square root of 3. And now you just have to know your trig values here. So tangent theta equals 1 over root 3 has the same meaning as saying, if we multiply the top and bottom by radical 3 over radical 3, that tangent theta equals radical 3 over 3. And then you might recognize this as tangent of 30 degrees or pi over 6 radians. So now, after we identify the quadrants, we're going to find the reference angle. And our reference angle here is going to be pi over 6. Because once again, tangent of pi over 6, this is a positive acute angle, is equal to square root 3 over 3, or we could say 1 over square root 3. So now that's our quadrant 1 solution. So we have theta equals, and our quadrant 1 solution is pi over 6. So this is from quadrant 1. But now, what is our quadrant 3 solution? Well, our quadrant 3 solution we could find, so we'll just say our theta in quadrant 3 for this is going to be equal to, we could say pi over 6 plus pi radians, because to get to quadrant 3, we're going pi, and then we're going the reference angle pi over 6. And that's going to be equal to 7 pi over 6. So that's our other solution here. And that's from just this equation. Now, if we look at this equation over here, this we could rewrite as tangent theta equals negative 1 over root 3. So for this one, we're also going to have the same reference angle, because notice the ratio itself is the same. This one is just negative and this one is positive. So we're still going to have the same reference angle. But now we have tangent theta is negative which means we're going to be in quadrants 2 and quadrants 4, because tangent is only positive in quadrants 1 and 3. So it's negative in these two quadrants. So then what we have to do to find the rest of our answer, we need to use our reference angle to find our quadrant 2 solution. So what is our theta in quadrant 2? Well, this time around it would be pi minus pi over 6, which would be equal to 5 pi over 6. So that would be our quadrant 2 solution. And now we need a quadrant 4 solution, which would be a full 2 pi but minus the reference angle pi over 6. So our quadrant 4 angle for theta is going to be 2 pi minus pi over 6. And if we call this 12 pi over 6 and subtract 1 pi over 6, that's going to be 11 pi over 6. So now we could write our final answer as a superset here. So what we have is we have 0, and then the next angle would be pi over 6. And then what we have up next, we have 5 pi over 6 is the next biggest angle here. And then after 5 pi over 6, pi would be next. And then after pi would be 7 pi over 6. And then next up we would have 11 pi over 6, because that's almost 2 pi or 360. And then the last angle would be 2 pi. Okay, so we have a lot of solutions here, but this is all of them. So we'll look at another example here, but now this time around we already have everything moved to one side, so that part's nice. And now we're going to set each factor equal to 0. So first up we have cosine theta equals 0, and that's going to be true when we have a theta value of pi over 2, which is also the same thing as 90 degrees, and then also 270 degrees, or 3 pi over 2. So these values I'm able to get really quickly because of the unit circle. So I would say commit to getting good at the unit circle. That's the key to finding these trig values in your head. And now next we're going to set 2 sine theta plus 1 equal to 0. And this, if we separate and solve for sine theta, that's going to give us sine theta equals, we could subtract 1 and divide both sides by 2. And that gets us here. So now that we set each factor equal to 0, for this one we have to identify the quadrants because sine theta is non-zero. So now we have A, S, T, C, and notice sine is negative, which means we're not going to be in these two quadrants. We're going to be in quadrants 3 and 4. So we identify the quadrants. Now the reference angle here, we have to think for the reference angle, I'm just thinking sine of blank. When is sine equal to just regular positive 1/2? And we're looking for the positive acute angle here. And this one, if we think about it carefully, is going to be 30 degrees, or we could say pi over 6 radians, like this. So now we're in quadrants 3 and 4, so our answers, if we find our quadrant 3 answer, we're doing pi plus pi over 6, which is 7 pi over 6, and then we're going to do 2 pi minus, so this is for our quadrant 4 answer, 2 pi minus 7 pi over, 2 pi minus pi over 6 is 11 pi over 6. So now we can just write out all of our solutions together. What we have is we have pi over 2, then 7 pi over 6, then we have 3 pi over 2, and then we have 11 pi over 6. So here are our 4 solutions. Okay, so last question here, we're going to start by adding sine theta to both sides. So we're going to do plus sine theta on both sides like this. And now we've got tangent theta, sine theta, plus sine theta is equal to 0. And let's just make that neater. That's not my best theta. All right, so we moved everything to one side. Now we're going to, well, first we have to factor this, and then we'll set each factor equal to 0. So we're going to factor out sine theta, and we're going to have tangent theta plus 1 left over like this. So now we're setting each factor equal to 0. So we want to know when is sine theta equal to 0. And this starts us off with the solution. We have 0, pi, and 2 pi. So there's a lot of repetition with these questions, but after a while you start to get the flow here. And that's not my best arrow. That's a better arrow. So now we have the other factor equal to 0, tangent theta plus 1. And we move the 1 to the other side. We're going to have tangent theta equals negative 1. And now we just have to think here. If you get a little bit jammed up, what you could think of is you could think of when is tangent equal to 1. You could think of when is sine. So just some ideas if you get stuck. Let's say you don't have a calculator. I think of when is sine over cosine equal to negative 1. So you could say when is sine theta equal to negative cosine theta. So this is just some ideas that'll help the angle jump out at you. And then the angle you should be thinking of after this, a little bit of thought, is that the reference angle here is going to be pi over 4. Because at pi over 4, I know that sine of pi over 4 is equal to square root 2 over 2. And that's the same thing as cosine of pi over 4. Okay, so that's how I'm able to come up with this somewhat quickly. But now what we have to think of, tangent theta is negative. So we do the quadrants, ASTC, if tangent is negative, that means we're not in quadrants 1 and 3. We have to be in quadrants 2 and 4. So our reference angle is pi over 4. So now we're going to find our two solutions here. We have a quadrant 2 solution. So we're doing pi minus pi over 4. And if you do pi minus pi over 4, that's going to be 3 pi over 4. And now we have a quadrant 4 solution. So that we would find by doing 2 pi minus pi over 4. And that would give us 7 pi over 4. So now let's write all of our answers together. We have theta equals, our first solution in order is 0. Then up next, we have 3 pi over 4. After 3 pi over 4, we have pi, then 7 pi over 4, and then 2 pi is our final solution.